No, seriously, I have no problems. And even though you guys are, I mean, seniors, I've had a couple of tough statistics classes, let me tell you. Real tough ones. Real tough ones. Where I yell.
Wow.
Yeah. Not pretty. You know when I yell, it's bad. Okay, so let's hit a couple more of these. We'll do one with a right tail test. We'll do one with an equal sign, and then you're going to do a couple. So a company claims, here's our claim. It's nice when we get the word in here. A company claims that the standard deviation, so what symbol for my population standard deviation do I use? What's my symbol, ladies? What's my symbol? Sigma. Good. Well, that was a good guess. So that the standard deviation, remember I'm making a statement about a population of the length of time it takes for incoming calls to be transferred to a correct office. Did we do this one yesterday? I think we did this one. Because I certainly remember saying incoming calls tongue-tied yesterday. So we did two yesterday, so let's just do one more. We have one more to do. An equal sign. Let's do the equal then. Did we do it, or was it just like before?
You did a breakdown, then like so, and you should never do a detail.
I did do 2 times today. Okay, the other one was the homework. Okay, good. All right, so let's hit example 6. Sorry about that. A sporting goods company claims, here's my claim, claims that the variance, and what population symbol do I use for variance? Sigma squared. Good. Of the strength of a certain fishing line is 15.9. So here's my claim. My claim, and you use the right parameter, sigma squared is 15.9. Is this an HO or an HA? HO because it has an equal sign. My not equal to is my HA. There's where my tails come in. Now remember, this is a little different, this graph. It's not equal, it's not even, but they're going to tell us that we have to assume the population is normally distributed. And they go from 0 to infinity. There's no negatives. So we label this reject HO. And fail to reject HO. And we have two critical values to take. They're both positive. And you can only use your table 6 for this. Okay, so you guys that were absent yesterday, table 6. Did you grab a table 6 in there also? The notes? Okay, I can get you a table 6 to use. We're back to table 6. In a few minutes. I'll give it to you in a few minutes. Now, remember, when you look up table 6, here's your level of significance. Pull out your sample data. You sampled 15. So what's your degrees of freedom? 14. Good. We looked at a level of significance of 0.05. We found a sample variance. Because it's in the same sentence, that's the sample variance. So now we have two tails. So we have to take your level of significance and divide it by 2. Same as we always did for our inverse norm and our inverse T. So we get 0.025. Now here's the catch. What's 1 minus 0.025? 975. These are the columns that we have to come down and look at. So on your table 6, degrees of freedom 14. Go look for 0.975 and 0.025. And come down, you'll get 2 numbers. The smaller number goes to the left. The larger number goes to the right. None of these is negative. So you're going to get 5.629. Good. 26.119. Good. This is the only difference, major difference with table 6. You have to first divide by 2, then subtract it from 1. Keep track. All of these critical values are positive. There are no negatives. And they're different if you remember back from our level of confidence. Now, your formula is not so bad. Here's my formula. 1 minus 1 is my degrees of freedom. So, my degrees of freedom, 14. S squared is my sample variance. If I have my variance, I just plug it in. Do I square it? No, because it's already my S squared. Then I take my population variance that comes from my statement. If it was my standard deviation, then yes, I would square it. But it's my variance, I do not have to square it. Put it in your calculator just like you read it. 14 times 21.8 divided by 15.9, and you get 19.915. There's no p-val for this guy. All reject region. I locate where this falls. Somewhere between here, it falls. So somewhere here, I write 19.915. And my decision, fail to reject H0. Okay, now if I fail to reject H0, that's this guy. Do I have enough evidence? Oh, so that's this guy. Do I have enough evidence to reject my claim or fail to reject my claim? I fail to reject my claim. I have to go along with this guy, but I have to say there is not enough evidence at a level of significance of 0.05 to reject the claim that the variance of the strength in a certain fishing line is 15.9. Okay. Remember, this is variance. Variance and standard deviation. Variance doesn't have a great meaning for us as standard deviation does, but variance is used when things are really small. And probably the strength of fishing lines has very little variance there. Are we okay with this? Do you guys want to try one of these on your own? Try it 6 before I send you off on your own here. Let's have everybody. All right. So a company that offers dieting products and weight loss services claims, there's our claim, that the variance, again, what symbol do I use for population variance? Sigma squared. Of a certain weight loss, the weight loss of their users is 25.5. So I set up my claim. This is my claim. Make sure you identify it as a claim. And tell me if it's HO or HA. It's hard to make an equal sign, a not equal sign claim. Then you'd say is not. So we pretty much have to go it the other way. Now remember again, you've got 2 tails on this one. And you're just labeling them both reject H0. I need these labeled reject H0 and fail to reject H0. You're going to find me 2 critical values. Neither one is negative. So a random sample of 13 users, 13, has a sample variance, it's in the same sentence as my subject of my sample, of 10.08. And I'm looking at a level of significance of 0.10. Is there enough evidence to reject? Reject tells me my claim is HO. Make sure first that you're lined up with that. Now, my degrees of freedom, 12. What do I do first to find my critical values? How did you look up your critical values? DF.
And then, what's that called?
level of significance.
Yeah.
That's okay. So I look up what for level of significance. Okay, so if I divide this by 2, I get 0.05, and the other part of 0.05 that's symmetric to this, 1 minus that, 0.95. I need 2 values. 0.95 gives you the smaller value. The smaller value goes to the left. No negatives on this. So 5.226 and 21.026. Is there anybody that cannot find those? Remember to divide it by 2. I think what gives you a good clue is, if you look at the top of 6, on table 6, your low level of significances are 0.05, 0.01, 0.10. Those are the ones we use. How did they get 0.025? How did they get 0.995? They got it by doing that. So remember to divide them by 2. Okay, so now your test information is going to go here. We take our degrees of freedom times our sample variance divided by your standard deviation, by your variance of your population, sorry. And you get, shh, ladies. So where does that fall? Behind this guy, before this. So what's my decision? HO. Not reject claim, reject HO. If I reject the claim, I don't like it. I'm not going to support this claim, but I got to use the right words for this. So I go to my chart, my claim is my HO, I reject HO, I say there is enough evidence at a level of significance of 0.10 to reject the claim that the dieting product's variance of the weight loss is 25.5. Done. Easy. Just don't forget this part. This part is the hardest part.
Dividing by 2?
Yeah, because if you look there, you know, you want, where did those like 0.025 and 0.975 come from? They didn't come just from your 0.10 or 0.90. So kind of keep track of that.